Calculus 3. It's all about a double integral for now. A double integral, it is the volume of a solid underneath the surface over a rectangular region, and certainly a double integral could be positive, could be negative, and because the surface could be below the xy plane or partly below, partly above. Okay. And most importantly, in this section, we said there are two ways to evaluate a double integral: y first, then x, or x first, then y. And sometimes the order doesn't make a difference. That's all about 5.1. How about a move to 5.2? It's still about double integrals. But keep in mind, in 5.1, we really only covered a very simple case. We are having a double integral over a rectangular region. And many times, we have a region which is really not a rectangle at all. So 5.2, we are working with double integrals in a general region. Specifically, there are so-called type 1 and type 2 regions. So let's take a look. The first three charts, and I want to tell you here, don't think too much. Make sure you do understand the first three charts. They are just for type 1 regions. So in general, type 1 regions should be considered as bounded by two vertical lines and a single curve at the bottom and a single curve at the top. That is a type 1 region. And also remember, we can use the cross product, well, AB cross CD to denote a rectangular region, and then to denote a type 1 region, it takes a little more space of writing. So in general, type 1 region can be written as x running from A to B. This really means the entire region is bounded by two vertical lines. And the second part of the inequality, y is bounded by G1 and G2. G1 is a curve at the bottom, and G2 it is the one on the top. Okay, y is bounded by G1 and G2. And then accordingly, for double integral over a type 1 region, it is always the case you are going to evaluate the double integral in terms of y first, then x. Maybe let me try to see if I can highlight the so-called inner integral. Yes, I can. Okay, this is the inner integral I'm talking about. I hope you take a close look. What would happen when we evaluate the integral in terms of y? Indeed, I would say everything about y will be gone because y eventually is replaced with x. So the integral really will give us something about x. And then you work with the outer integral, which means we are going to integrate with respect to x. Then in the end, x it is replaced with b and a. So the double integral, it is a number. It is a number. Okay, it is a volume. It is a volume. Okay, this is type 1 region. Well, let's move to type 2. Type 2 region, in words, it can be summarized similarly. It lies between two horizontal lines. Look at those two lower charts, two lower graphs. Okay, each it is bounded by two horizontal lines. A single curve to the left, I say that's a smaller curve. A single curve to the right. And also be very careful, I say the curve. Okay, the representation of the curves in the type 1 region, we say y is a function of x. Okay, in the type 2 region, we say x is a function of y. X equals h1 of y, x equals to h2 of y. The other chart really about the same situation, type 2 region, type 2 region. And then accordingly, if we are looking for the algebraic representation for the type 2 region, And this part of writing, I did it a little differently from a textbook. Somewhat, I do like the idea always keep x first and y. Okay, but practically you may want to know because of the way how we treat a type 1 and type 2. For type 2, y is bounded by two constants. So y is running from c to d. And then x is bounded by two functions, h1 to h2. X is a function of y. Certainly for now, if I keep on talking like this, it may not make a lot of sense. When doing the actual problem, you will see what I mean by type 1 and type 2, how we make arrangement for the upper bounds and the lower bounds for x or y. Okay. And now let's stop pretending everything's fine and take a quick look at how a double integral it is evaluated over a type 2 region. So it will have to be evaluated in terms of x first, then y. And still you want to take a close look what would happen after first round of evaluation. I'm seeing after first round of evaluation, we are still going to have a bunch of y's left. So it makes sense. We can continue to integrate with respect to y. Then in the end, we plug in two values for y. Okay, upper bound and lower bound. So the double integral turns to be a single number. Double integral is a single number. So this is in general how we consider type 1, type 2. And also, I did give the result. When you have type 1 region, the double integral should be evaluated using y first, integrated in terms of y first, then x. And then accordingly, for type 2 region, it should be integrated in terms of x first, then y. Type 1, type 2 regions. How about let's take a quick look at some examples. I believe the example, it is from the textbook. And checkpoint 5.7. And it is considered region bounded by two simple curves. And actually, if you read the requirement, I'm not sure if it's surprised or you are surprised or not. Because a moment ago, we said that type 1, type 2 sounded different. But anyway, practically many times you will see you have a single region, it can be considered type 1 or type 2, or really both, in both ways, okay. So this is what I did. First, I tried to sketch the graph. And again, usually for this type of problem, you do need to show the graph. Okay. And then after drawing, roughly, making a sketch, I see there is a region between those two functions. Y equals 2x and y equals x squared. And this is the region. And then I said it doesn't make sense. I'm saying describe this region as type 1 and a type 2. Remember in type 1, we said it will have to be bounded by two vertical lines. I think it does fit. X running from 0 to 2. So x running from 0 to 2. And then y value, it is running from this lower orange or brown colored curve in the lower place and the blue line on the top place. So I'm saying y is changing from 2x to x squared. Am I correct? I think I should switch these things. Y is changing from x squared to 2x. Because x squared, it is in the lower place, right? Yeah. Y is changing from x squared moving upward to 2x. It should be in this fashion. Okay, type 1 region. So this is how we describe a type 1 region. And for type 2 region, and now I'm saying, remember type 2, it is always bounded by two horizontal lines. Actually, it does fit. Those two horizontal lines just simply means y is changing from 0 to 4, so it still fits. And then there is a single curve to the left, a single curve to the right. Okay, left, it is smaller x value. right, it is a bigger x value. So to the left, it is the line. And now I just figure out I need to change this into square root of y. Left, yeah. Right, it is the square root of y. And then the left, it is from the line. And I hope you see somewhat. I did not write y equals 2x, right? Because I needed to have a band for x. So I write this as x over y, x equals y over 2. So the same region, it can be considered in this case either as type 1 or type 2. Either as type 1 or type 2. And remember, we are talking about double integrals, right? If we have a double integral over region which can be considered type 1 and a type 2, which really means double integral can be evaluated in two ways. Okay, so, but anyway, the final answer should be the same. So this is the beginning of 5.2. We are identifying type 1 and type 2 regions. And make sure you do know how to write in general for the type 1 region, for the type 2 region, and then you know how to evaluate a double integral over type 1 region, type 2 region. And also there's another thing we mentioned, and we said sometimes a region can be considered in both ways, type 1 or type 2. Hey, thank you for watching. I'll see you next time.